For this question, it's given that a block of mass 2 kg rests on an inclined plane at an angle of 30 degree with horizontal, and the coefficient of friction between the block and surface is zero point 0.7. We have to find the frictional force acting on the block. So let's say this is a block that is resting on an inclined plane, making an angle of 30 degree. Okay, let's say this is the block and this is the angle of inclination. Now its weight will be acting vertically downwards. So this is the weight which is acting vertically downwards. This is mg, and it has two components, horizontal and the vertical. Horizontal one is replaced by the normal direction r. And this is mg cos theta, and this is mg sin theta. And because this will be sliding downwards, so the force of friction would be in the upward direction. Okay, we have to find the force of friction acting between the block and the surface. Okay, it's given that the coefficient of friction between the block and surface is 0.7, and we know that the coefficient of static friction is given by the force of friction and divided by the normal direction. So this is force of friction would be equal to mu s into r. This is the coefficient of static friction, which is 0.7, and r is balanced by the horizontal component, which is mg cos theta. So let's find out this. This 0.7 mass is 2, g is 9.8, and theta is 30 degrees. So this is cos 30. So 0.7 into 2 is 1.4 into 9.8. Cos 30 is 3 by 2. This friction will be in Newton. Force of friction will be in Newton. Okay. So if we calculate these values, 1.4 into, this is 1.4 into 4.9 into the value of root 3 is 1.732. That should give me 11.88152. So this is equal to 11.88152 Newton, and this is because of the multiplication of 1.4 into 4.9 into 1.732, which is the value of root 3. And if we round this up to 2 decimal places, so this is, or this 1 decimal place, this is 11.9. So 11.9 Newton is the force, frictional force acting on the block. Thank you for watching.